Hi math students, and welcome to today's lesson, or I guess video, which is a review of all the lessons we learned in Unit 3. We are going to start this off with our first of 4 questions. This first question says, what inequality sign should go between the two problems? Justify your answer. The first problem says 1/3 plus 5/9, and the second problem says 2/5 times 1/4. Question is, what inequality sign should go between those? Go ahead, try it now. All right, well, to figure out what inequality sign is going to go between the two of them, we need to know the value of each of these sides. For this side here, we've got a fraction addition problem. In our lesson on adding fractions, we learned that in order to add two fractions together, the denominators need to be the same. Right now, they're not the same, so we're going to have to change one of those fractions. I'm going to change the fraction that has the smaller denominator using multiplication to look like the fraction with the larger denominator. So that 5/9 is going to stay the same, and I'm going to ask myself, what's an equivalent fraction to 1/3 that also has a denominator of 3? The way we figure that out, like I mentioned, is using multiplication. I notice that 3 times 3 gives me 9. So that's going to be the number I'm multiplying both the numerator and denominator by. My denominator 3 times 3 gives me 9. My numerator 1 times 3 gives me 3. What we figured out is 1/3 is the same thing as 3/9. They're equivalent fractions. They're just using different numbers. Once I've done that, I can go ahead and add those together. 3 plus 5 gives me 8. And then when you are adding fractions, that denominator will stay the same. So 3/9 plus 5/9 equals 8/9. Now for the other side, we've got a fraction multiplication problem. We learned when you are multiplying fractions, it does not matter if the denominators are different. You can just multiply straight across. So we're going to say 2 times 1. That gives me, I'll put it over here. That gives me 2. And then 5 times 4, that gives me 20. Now for this one, there's something else I can do. I notice both these numbers are even. That's a clue that I can simplify. We simplify by finding a common number you can divide both your numerator and your denominator by. I notice they're both even, which means I can divide both of them by 2. If I do that, I'll put it down here. 2 divided by 2 gives me 1, and 20 divided by 2 gives me 10. So I've done all this math to figure out this left side here is equal to 8/9. This right side here is equal to 1/10. The last part for this problem, remember, it's asking for an inequality sign. What are inequalities? Well, inequalities were those less than or greater than signs. So I'm trying to decide here, do I want to use a less than sign, or do I want to use a greater than sign? This goes back to our lesson on comparing fractions. I'm going to look at these two fractions and ask myself which one's bigger, which one's smaller. We talked about a lot of different strategies you can use to compare these. The strategy I would be using for this one is comparing them in my head to a half. If I know one of them is bigger than a half and the other one's smaller than a half, that's going to help me figure out which one's bigger. If I'm looking at these, 8/9 is bigger than 1/2. A lot of different ways you can come up with that. One is just simply picturing our favorite thing ever, right? When we're talking about fractions, a pizza. Picture a pizza that's divided into 9 slices. If I eat 8 out of those 9 slices, I have definitely eaten more than half of a pizza. So this one is definitely greater than a half. You could do the same thing for 1/10. If you only have 1 out of the 10 parts, if you have a pizza that's divided into 10 slices and you only eat 1, that is smaller than 1/2. Just by doing that, that helps me know that this fraction here is greater than our other fraction. So I'm going to be using the greater than sign. To justify my answer, there's a lot of things you could say. For me, I would probably say something along the lines of, on the left side, I added those fractions together and got 8/9. On the right side, I multiplied those fractions together and I got 1/10. And I know 8/9 is greater because 8/9 is bigger than a half and 1/10 is smaller than a half. That's going to look different if you compared them in your head differently, if you used a different strategy, but you should be getting these same numbers here for at least the first part of your answer. I like this question a lot because it reviewed a lot of different things. It reviewed finding equivalent fractions. We do that by multiplying. It reviewed adding fractions. When you're adding, remember those denominators need to be the same. It reviewed multiplying fractions. Remember, when you're multiplying fractions, you're just multiplying straight across. It reviewed simplifying, which is where this came from. Remember, you use division to simplify. And it reviewed comparing fractions and those inequality signs. So there's a lot of math behind this question. The next question we have looks like this. We've got Bob has 20 animals on his farm. Half the animals are cows and 1/4 are horses. The rest are pigs. How many pigs does he have? Go ahead and try this one now. So for this one, I want to quickly review what they told us. They told us there are a total of 20 animals. What type of animals does he have? Well, he's got some cows. He's got some horses. And he's got some pigs. So he's got 3 types of animals here. In order to figure out how many are pigs, it tells us the rest are pigs. I'm going to need to know how many are cows and how many are horses. Once I have that information, I'll be able to figure out what's left over and know how many pigs there are. Now, they don't tell us the number of cows. What they tell us is half. They say half of the animals are cows. So I know that half of these 20 animals are cows. Now, some of us might be able to just read that sentence, half of the 20 animals, and know how many that is, know a number. If that is you could go ahead and just write down that number. If it's not, there is a type of math we learned here. If you have half or a fraction of something, we learned that that is describing multiplication. So I could come in order to figure this out and say 1/2 times 20. We also learned that when you're multiplying fractions, it helps for both of those to look like a fraction. So I could write 1/2 times 20, but I'm going to write 20/1. We learned that if you want to make a number look like a fraction when it's not a fraction, you make that denominator 1. When we go to multiply, we'll multiply this just like we did in that last problem. I'm multiplying straight across. It's going to say 20/2. When we go to simplify that, you can simplify by dividing like we did last time, or because my numerator is greater, I could check to see, can I just divide? This says 20 divided by 2. 20 divided by 2 gives me 10. So I have figured out that there are 10 cows. I'm going to come back and put that over here. We've got 10 cows. That's our first part. For horses, it tells us 1/4 of those animals are horses. So similarly, I know 1/4 of those 20 animals are horses. The math will look the same. I know you've already tried this question, so maybe you already know the answer for this one, but go ahead and tell me just how many are horses. To do that, it's going to look real similar to what we did last time. It'll be 1/4 times 20/1, which gives us 20 divided by 4, which is 5. So we know that there are 5 horses. Remember the question. We are trying to figure out how many pigs does he have. At this point, we know there are 20 total animals. I know there are 10 cows and 5 horses. So how many pigs are left? Well, if I add these together, it means there are 15 cows and horses. If I take that away from the total animals, that tells me there are 5 pigs. So to answer this question, we would say there are 5 pigs. Now, if you were thinking about multiplication of fractions, this is one way you can do it. There is another way you can do it. For my visual learners out there, you could go back to what we had learned about modeling fractions and model this with a picture and use your picture to get the answer. So for example, we're starting off with 20 animals on the farm. I can literally draw a picture of 20 animals. My animals are just going to be X's for now. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Remember, I'm drawing them like this because it goes back to our lesson on arrays and multiplication. This is going to be a lot more helpful than just having random X's everywhere and not any sort of rows or columns. So I've got my 20 animals here. It tells me half of those animals are cows. If I wanted to divide this group in half, I'm just going to go right down the middle here. Half of them are cows. So in my picture, I can see that, I'm going to label them. All of these are cows, and there are 10 right there. It's the same thing we figured out with our multiplication. It tells me 1/4 are horses. Right now it's divided into halves. If I want to see how many 1/4 is, I want to divide it into 4 parts. So I'm going to come in and say, okay, right now it's divided into 2 parts. I've got 4 rows, which makes it real easy to divide it into fourths. I'm just going to come in and divide it right there. Now when I do it, it said 1/4 are horses. So 1 out of those 4 rows are horses. Well, it would be one of these rows. It doesn't matter. I'm going to make this row horses. Horse, 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 horse. And now I've got 5 horses. Also, the same number you figured out from that multiplication. The last sentence says the rest are pigs. Well, how many animals are left over? There are 5 there. So we get these right here are pigs. Not all the time are these problems going to be so easy to draw, but for this one here, since we had a whole number, it makes it a lot easier. And I like this as an option too, even if it's like what we just did now, where you do all the math first and then you kind of check your answer with a picture. I like having a visual just to make this all make a little more sense for myself. This was our second review question. We'll keep us moving right along. The next question says, what is cheaper, buying a $1,000 TV that is half off, or buying a $550 TV that is 10% off? Explain your reasoning. Go ahead and try this one. This is coming from the lesson we did for you all. It would be on Thursday on converting fractions, decimals, percents. That's where this one here is coming from. Go ahead and try it now. All right. So similar to that first question, we were comparing the 2 fraction amounts. That's really what this is getting at, is comparing the 2 TV amounts and seeing which is a better deal. I'm going to start off with this first TV, a TV that costs $1,000 that is half off. So our first option is the $1,000 TV that is half off. There's a couple different ways you can figure this out. If it is half off, it means I need to find out what half of $1,000 is. One way you can do that is the same as what we just did with the pigs and the horses, is take 1/2. What is half of $1,000? The other thing with a half is taking a half of something is the same as dividing it in 2. You're thinking about like a shape. Anytime we wanted to draw a half, we were dividing it into 2. Same idea here. If I want half off that TV, all I need to do is say to myself, well, what is 1,000 divided by 2? Either way you do it, you're getting that $1,000 TV at half off costs, I'll put it in red here, costs $500. Half of 1,000 is 500, or 1,000 divided by 2 is 500. So that's your first option, is this TV with that discount is going to be $500. What about our other TV? Well, this other TV we've got is $550, and it's 10% off. So for this one here, we need to figure out what that 10% off is. We need to figure out how much money you're saving if it's 10% off of that original cost. When we did the lesson on decimal fraction percent conversions, we learned that if I want to find what 10% of this is, I'm going to rewrite it like that, 10% of 550. We learned again that word of is telling you it's multiplication, but we need to change our percent into a decimal to multiply. If I am doing that, to change it to a decimal, we're just moving that decimal point over 2 and we're getting 0.10. This would be what I need to multiply. When I multiply 550 times 0.10, we are going to get 55.00. Now my question is, what did we find by doing that? What is 55? Well, that's the 10% off, which remember is the discount. So I figured out at this point that my discount is $55. That does not mean the TV is $55, just that you're saving $55 on the TV. So if I want to find out what that final price is of the TV with this discount, I'm going to have to take that original cost, the $550, and subtract our discount, the $55. And when you do that, you get the final cost of the second TV is going to be $495. So to answer the question, which one is cheaper, it would be the second TV. To explain your reasoning, I would just summarize what we figured out here. I would say the second option is cheaper. I figured that out by finding what half of the $1,000 TV was, which was $500. The second TV, 10% off, would be $55. So the second TV, the final cost would be $495. And $495 is cheaper than $500, something along those lines. The main things I want to emphasize for this one here is when you are finding a percent of a number, remember you want to change it into a decimal first and then multiply. I didn't do 10 times 550. I had to change that to my decimal form, which is 0.10, or you don't even need that 0 at the end. You could have just used 0.1 and then multiplied the decimal by that original total cost. We've got one last review question. The last review question says, Chris made a goal to lose 15 pounds over the next 3 months. In October, he lost 8.4 pounds. In November, he gains 1 pound. And in December, he lost 7.8 pounds. Did he reach his goal? Explain why or why not. Go ahead and try this one. All right. So in order to figure out if he reached his goal, we need to figure out how much total weight he lost over these 3 months. They told us 3 things. They told us in that first month, he lost 8.4 pounds. The second month, he gained a pound. There's a couple different ways you can do this. I'm going to start off just by focusing on calculating how much total weight he lost. So this isn't weight he lost. And then in December, he lost 7.8 pounds. So the strategy I'm going to use is let's figure out how much total weight he lost first, and then go back to what happened in November. So to figure out how much total weight he lost, it's the 8.4 pounds plus our 7.8 pounds. When I add those together, I'm adding my 4 and my 8, which gives me 12. 1, 8, and 7 gives me 16. And then we learned when you're adding or subtracting decimals, these decimal points here just carry down and we get 16.2. What did I just figure out? Well, I figured out he lost 16.2 pounds. Now I have to go back to November because he's trying to lose a total of 13 pounds over these 3 months, but he gained 1 pound there. When I go to show that he gains a pound, that's weight he put on, so I'm going to be adding it back. It's weight he gained, so he's adding it back on to his total weight, or you can think of it as he's subtracting it from the weight he lost. So I want to take away 1 pound. How should I write that 1 pound? That 1 pound, remember when you're talking about adding or subtracting decimals, those decimal points need to line up. So I can't put 1 right here because that would mean 0.1 pounds. When I write my 1 pound, I need to write it as 1.0 so that those decimal points line up. When I subtract that out, I get 15.2 pounds. He would have lost 16.2 pounds, but he had gained that 1 pound, which meant his final weight loss was 15.2 pounds. His goal was to lose 15 pounds, so did he do it? You could say, yes, he did, because he lost a total of 15.2 pounds. Now, I said there is 2 ways you can think of it. If you were looking at this and remembering what we had done back in Unit 1 with negative numbers, that is the other way you can do this. So his goal is to lose 15 pounds. When we say he lost 8.4 pounds, you can think of that, since it's a loss, as a negative number. So you could think negative 8.4. When he gains a pound, he's adding on a pound. So that's plus 1. And then he's lost another 7.8 pounds. When we go to do this math, one of the things you could do is start by saying, I'm going to look at the negatives. When you have 2 negative numbers, what do? Well, if they're both negative, you add and keep the sign. Notice that's the same thing we did here. I'm adding those 2 numbers and then keeping the negative sign to show that that's weight he lost. The second part, I've got different signs here. Well, what do you do when you have different signs? You subtract. Look, that's what I did here. And that would end up giving me negative 15.2. If you're doing it with integers, that negative is just showing its weight he lost. But because I'm not asking you to represent it with an integer or anything, you don't necessarily have to do the problem with negative numbers. But if you were thinking about negative numbers, it's definitely an option for this one. This was the last review question I have for this unit. Remember, I always focus on review questions that are questions students more often struggle with. So these were definitely some challenging questions. Please make sure before you take that unit assessment that you have gone back in and looked over all of the feedback on the homework assignments that you've already completed that have been returned to you. If you do not know how to do that, please reach out to me or Denise and we will show you how to do it. I think that feedback is so important so that you can see which questions you're getting right, which ones you're getting wrong, before you go in and do that test. There's also a unit review assignment for you guys to do for this review day that will also go over some of the other questions that we want to make sure you know how to do before you take that test. Thank you so much for watching. Bye.